Yeah, good afternoon. For today's lecture topic is the applications of advanced geospatial tools for urban hazards. I'm Pramod. I'm working at Indian Institute of Remote Sensing, Dehradun. Now, this topic has got high relevance in the current context for the reason well known that as the urbanization processes are increasing, and so is the it's also becoming the cause for rising urban disasters. In this context, that's how the topic is, and then we are going to deliberate over 1 hour session that how the geospatial technology can be used for understanding the various kind of hazards which are affecting our society and the urban areas. So as such, the contents which I'm going to deliberate in the 1 hour session, that I'll discuss a very some of the basic aspects at how the urban hazard and risk and vulnerability aspects they are being covered, what is their relevance. And then these kind of hazards or the disasters when it strike our society, then what are the different economic losses which has been computed by various agencies for the India, our country, and also as a global. And when these processes are happening, and what are the causative factors? One of the important causative factor is rising urban population. So what are the methods which are being used, and then what kind of products are being made available where we are able to assess the urban population and although the urban built up mass. Then in the urban areas, then with this all background, I'll move that what kind of different kind of hazards are there which are inflicting the urban surfaces, what are different kind of data sets, and then I'll move on to the applications. And then though the field is quite large, and but I'll touch upon with the time given in depth for some of the applications like the urban flood hazard or the risk analysis, seismic risk analysis, fire risk analysis, urban pollution, and the heritages, urban heritage, which are present in the society, and because of the various disaster which strike or because of the aging process, then how this urban heritage get affected and what is the technological solution available to assess the hazards. Now, with this, I'll move to the lecture content. As such, you already aware with the because this lecture is, the course program is ongoing. Already, it must have been taught that what is the difference between hazard, risk, and vulnerability. As such, risk is a composite of the urban hazards and vulnerability, where the urban hazard speaks about that what are different events or conditions which has got potential to cause any kind of damage to the infrastructure, environment, or and which interrupts our day-to-day process. Vulnerability is the nothing but the exposure. With the vulnerability, it relates to the society or the infrastructure, and how because of the coping capacity, based on the coping capacity of the individual or the society or the infrastructure, whether we are able to cope up with the hazards which may come to a particular landmass, or are we not equipped enough? And then, as a matter of fact, that when we take into the urban hazards and the vulnerability together, we are able to assess the urban risk. In this context, as such, the geospatial technology is offering us, as we'll see in the course of this deliberation, that how we are able to map it, to monitor it, and to model it so that in the phases of urban hazard and risk modeling, because we have got phases like the preparedness, or at the later stage we have got the relief and restoration, how the technology can help you to create some kind of alert to figure out the areas which needs the attention, or at the later phase when the disaster has struck, then what can be done. So as such, the economic losses due to these various kind of hazards or the disaster which strike our society, they are large. And when you look at the globally, by various agencies or agencies in the country as well, they have assessed Among these losses, if you take it, the major causative factors are the seismic or the floods. Beside this, our societies also gets infected based on the city typology. It also gets affected because of the tsunami, if the coastal cities are there, or because of the storm surge, or because of the high velocity winds, which may also affect some kind of economic losses. If you take it India, then again the larger losses again they are caused by the floods or the also because of the earthquake. But beside this, because of the our peninsular characteristics of our land mass, we've also got that large land mass is likely to get affected because of the tsunami. So this how these kind of disasters, if they strike, their potential to cause the damage to the man and the society and the infrastructure is quite large, and it affects the life and the property, and also it will disrupt the transport and power. And then once this all disaster strike and at the later stage, because it may also cause some kind of epidemic. And say, for example, when the water logging or the urban flood or the floods are there, then it will also cause the epidemic. And then this all causes because the life get disrupted, and that's how our society and the losses to the business and the industry, that's also quite large. Now, one of the major causative factors is the rising urban population. Why so? Because it is estimated that nearly 3 to 4% of the Earth's land surface, they are under the urban, they are under the built up. Now we have got data sets which using which we are able to quantify that how much area is under the built up. And in that context, the data layers like the global human settlement layer or the global population grid, they are the two important data sets, and they are the part of Atlas of the Human Planet, which based on 4 epochs, that 1975, 1990, 2000 and 2014, 15, we are able to assess now how much the area is there under the built up. And if you take it based on census characteristics, and then based on the rising population, because there's a large influx which is happening to the cities, then that's how the urban population is expected to rise ever. And this, when the urban population is rising, and because there's a large scale influx migration to the urban area for the rural segment, that's how the rural population is declining and the urban population is rising. Now, as I said, we have got now the data sets, and subsequently this exercise is also being extended to using the Sentinel data. We are able to find out that how much the area is there and the built up. Now, this population influx, when it is happening to the cities, then several some segment of this population, they reside particularly at the areas which are vulnerable. They will be close to the river, and then it will be close to the water bodies, close to the rivers, or it will live in housing areas which are vulnerable, which has lived, where the structure has lived its life and it is not safe. That's how, because of the economic reasons, such kind of population are forced to stay in those pockets, and they become vulnerable to various kind of urban hazards. So there are studies which state that based on variety of hazards, then what are the vulnerable areas which are there globally. And then accordingly, some studies have been carried out at the behest of the United Nations and trying to figure out that areas across the globe where the hazards are in the 3 decile, that means in the the population group of tens, 3 tens, and the areas which are in one hazard in top 3 deciles, areas in the top 3 deciles, and the 3 plus hazards in the top 3 deciles. You see several of these high risk zone, high hazard zone areas, they are located in Asia, in the South Asia, Southeast Asia, and also they are located in some in the Southern America. So that's how such kind of mapping has been made possible, because of the variety of data set which are available, which have been collected from the ground resources, or they are collected from the satellite-based remote sensing data sources. So as such, whenever these kind of disasters they strike our urban areas, they affect variety of resources, and such resources may be transport, it will be the building infrastructure, and it will be also affect the population at large, and depending on the disaster characteristics, it will also affect the environment. For example, environment get polluted and it will also destroy the biodiversity characteristics, etc., etc. Why so? All these disasters are occurring because the traditional manner, no, whenever we think, play with the nature, no such things are going to happen. Either we tend to encroach into the river floodplains, or when we the informal settlements, they come and they get mushroomed close to the rivers, or they are lying in the high vulnerability or high seismic risk zone areas, and where the building practices they are inferior, or wherever because of the safety norms they are not being practiced, or there will be because of the several climate induced factors like the dust storm and the cyclone. So as such, there are a variety of reasons, and these reasons can be grouped into broadly two categories. One first reason is the first we ourselves are responsible, and there is the second is the fury of the nature. So as such, when the coping capacity is not present, that's how the society will get affected, and then the disasters are going to strike. Disaster may strike at any region, but if the coping capacity is not there and the population density is very high, that's how the casualty or the damages to the society and the infrastructure is going to be large. So that's how such losses will be high if we are not prepared, do not protect ourselves, or we are not able to respond effectively, and we have not made ourselves resilient. So that's how we have to keep in mind that how to minimize such losses. As such, the urban hazards, they are broadly categorized into six categories. First is physical. Physical means, and this all categorization is based on the sources. Now, the physical is dependent again, it may be man-made, and also a combination of man-made and also the because of the extreme events, because of the anomalous behavior of the weather in the or the climate in the region. So this will be because of the seismic or earthquake, flood, the noise, because of the kind of instruments or the kind of vehicles or the industry present in the area. It may be because of the lighting, fire and explosion. Chemical will be largely based on because of the industrial practices, or because of the playing with the nature, or because of the extreme events, because of the anomalous behavior of the climate or the weather. Now, ergonomic characteristics will be because at a workplace, because the tools and equipment they are not placed well, or because of the insufficient space, or we are not able to handle them properly. That's how the ergonomic reasons will play the role. Radiation will be again, it will be the man-made, or it will be natural as well. If we are located in a region where because of the certain biophysical characteristics we are exposed to the harmful rays, or because of the presence of the industry, or because of the presence of the nuclear power plants, such will cause the radiation kind of hazards, or because of the war as well, such kind of hazards are likely to occur. Psychological is because of the different kind of work pressure, or because of the several reasons is all we know about. And the biological is becoming relevant now, especially in the recent times. That's how the pandemic, or because of the recent past, we have had several such instances where the viruses or different kind of mosquito genic and other kind of reasons, they have inflicted our society and the population got affected. So in this way, the urban hazards are categorized into 6 categories. Now, once this all urban hazards which are likely to affect our society, and then based on, as I said, based on the coping capacity, the urban risk will again is categorized into broadly 5 categories. And first is environmental. So risk is to the environment in general. The risk is will be because of the loss to the infrastructure. The risk will be dependent on the because of the kind of policy, or depending on the reputation of a certain place has. So if any kind of disaster when it has struck, the people will be afraid to visit in the times to come unless any remedial measures have been taken and it is well publicized. There will be social or cultural because of the variety of reasons and where our resources has got affected. And then finally there will be a loss, economic loss to the individual, to the society, or to the businesses, or to the industry, or the government as a whole. That's how the risk is categorized into 5 broad categories. So as such, when you want to carry out the risk modeling, as I said, risk is a subject of hazard and vulnerability, and that's how variety of information we put in to understand the first of all the hazard. And depending on the hazard characteristics, we try to collect the information. For example, if it is the flood hazard, then we have to first of all look at the extreme meteorological phenomena, particularly the precipitation, and then we look for the extreme events in terms of based on return period analysis, and then we try to find out what is the coping capacity, and then finally we try to assess what kind of damage is going to occur based on economic, social, or other environmental characteristics. Finally, the risk assessment is carried out. So that's how, when the variety of data sets, when you have to handle, certainly the geospatial technology is going to be very, very helpful. So as such, the data which is going to come, it is of variety from platform. Now, this platform will be the remote sensing driven, and this remote sensing from variety of platforms, from the optical to the microwave to the thermal and beyond. And other like the hyperspectral or otherwise also several kind of data sets that is going to come from the satellite remote sensing. One has to also collect the variety of data sets which are not feasible using the remote sensing data sets, like, for example, any kind of administrative boundaries, or it may be like the demographic profile where the data sets are typically not available and where the value added products are not available. Then we have to look also from the data from the ancillary sources, and then we might have to go to the ground, and then we have to go to the map accuracy verification that we have to carry out, and then we to go for the hazard mapping. So then where the hazard will be based on some kind of extreme event phenomena, and based on the vulnerability will come from the practices what we follow. And then based on this one, as I said, the risk assessment is done. And when we have done the risk assessment, again the output, when you overlay over the some of these layers where for example the buildings are present, for example the urban population layer is present, then we can find out what are the population that is likely to get affected, which are the buildings which are likely to get affected, and then if you apply some kind of remedial measures, then what is the cost of remedial measures? For example, if you want to, in the case of urban floods, suppose in the case of urban floods, then remedial measures will be looking for the improved drainage plans. So in the context of improved drainage plan, that will have some certain cost. So that cost vis-a-vis the benefit which is likely to be accrued. So if you do this kind of analysis, the cost benefits analysis is possible, and then we can say that this is how the techno commercial kind of techno feasibility, techno economic feasibility can be assessed, and this can go towards the planning processes. So as such, these kind of data sets, they can be derived either from the satellite remote sensing, it can come from the aerial remote sensing, and in the recent times, the UAV remote sensing has become very, very popular for the reason because in the urban areas, based on density characteristics, it may not be feasible to understand the building and its characteristics. For example, adjacency of the building and kind of building related properties that may not be feasible to understand from the higher altitude platforms. That's how then one has to resort to the UAV remote sensing, which will yield the product of high spatial resolution, and then where we are able to distinctly observe each individual building and its properties can be assessed, which would be helpful for the hazard assessment. So you're already aware. So these kind of data sets are helpful. First of all, we all understand that if we are equipped ourselves before the disaster strikes our society, or the cities, then if we equip ourselves in the preparedness phase, then that is the best one. There's no solution, and then we can do the capacity building and we can prepare ourselves. Otherwise, it will have to go to the response, the relief, and the restoration phase. So because our coping capacity was weak, that's how the subsequently we have, once the disaster has struck, then only the other process will come in. Otherwise, not only, as I said, remote sensing data is helpful not only for the mapping, we can also do the monitoring, and also we can go for the modeling processes. That's how we can do the modeling and try to find out for a given kind of hazard, and based on variety of inputs, we can prepare our preparedness. That these are the zones which has got high vulnerability, moderate vulnerability, or low vulnerability. So those areas which has got low vulnerability, those areas we have to equip, and where the remedial measures they have to be carried out in advance, so that we equip ourselves to sustain those kind of disasters. Now let us see some of these examples which fall under the category of preparedness. So as I said, know that remote sensing data is helpful for the mapping and also for the monitoring. Now you see, for example, the many kind of disasters, they are affecting our society because the urban density is rising. So in the process of urbanization, what is happening that the people, some urban settlements, they are coming up in the areas which are very important for preserving our environment. And one such, two such characteristics are preservation of water bodies within the urban areas and preservation of urban green spaces. Why so? For the reason being that the water bodies, they absorb the water during the peak time, and they release the water during the lean time. So that's how the traditional, cities in the yesteryears, they were capable enough that because though technological means were not so high, even then people know they used to visit such water bodies, they used to fetch the water during the lean time, and the flood incidences were also minimal. But you see here that some metro cities within our country, that's how we are losing our wetlands, we are losing the water bodies, and they are burdened with the urbanization processes. So you see that that's how the quality of life, there also that is deteriorating, and it is causing various kind of losses. And there's nothing, the time series images which that has been captured, and that is helpful. I mean, that's how the urban managers, decision makers, they have to earn such kind of ready to use products which are available in the public domain. They have to periodically visit and to identify those areas where such kind of incidences are happening, and then regulatory measures have to be brought about. That's how we did that. There are studies which has been carried out across the country by the various agencies, and they try to see what is the loss of water bodies. And these are the studies which are not done by the remote sensing. They have been primarily done using the traditional methods. But the remote sensing data offers a ready-to-use faster tool to assess that how, with the as you can see, that how the over a period of time since late 1960s to the recent time, that's how the water bodies, they are diminishing at the cost of rising urbanization. So if these are the causes, then we have to, and these are leading to several kind of disasters. For example, the urban floods and the urban seismic, and also several other kind of disasters like the urban flood, fire risk, and several other things. Because when the such kind of population pressure is there, certainly it will add to several negative points within the city environment, like the people will forego the necessary building bylaws, and also the fire prevention policies that also will be ignored. So that's how these are the provision available in public domain, where we can see that how we are playing with our environment in the city environment, and that's what we are losing and what are we gaining. So when these processes are happening, now we are losing our water bodies and the green spaces. Then you see that in the recent times it is giving rise to the rising phenomena of urban floods and waterlogging. We in the recent times, in the previous times, we never used to hear that the floods incidences are rising, but this is happening year after year, whether it is 2021, 2020, or the 2019, or before that, several cities in the country, that one after the another, that the flood incidences are rising. So we carried out a study just to demonstrate that how the geospatial technology can be used for the urban flood hazard and urban flood risk modeling. So we have taken, though we have conducted the study for several cities in the country. One such example is the Bhubaneswar. You see that Bhubaneswar, that was as the top ranking city when the government announced in the 2016 the list of a smart cities. Though it is largely a planned city, but some parts of the city, it faces the urban floods. And in the such on the streets, the water remained stagnant for several days. So what we did, that we have used variety of data sets, and also we have used the model, and that's an open source model. Then we have got other commercial software as well, but we have used the stormwater management model, and we try to assess what are the causative factors. We also try to assess what is the risk, what is the hazard, and also we try to assess that what kind of risk is going to come as the extreme event phenomena they occur and affect the city. So now, in terms of causative factors, what is happening, that our agencies in the country, they are monitoring the river water regularly. You see that they have tried to monitor that during recent year, for example, in the 2019 and earlier, in various months of monsoon, the extreme events phenomena, they are rising. You see here, extreme event phenomena, they are rising. So it was found that Indian rivers have crossed the highest flood level at 37 gauge and discharge monitoring site. So that's how the extreme event phenomena, they are rising and they are being monitored by several agencies in the country. If it is the meteorological phenomena, there is agency. If it is the river discharge phenomena, that is also being monitored by the agency in the country. So such kind of instances are rising. So this is one fact which will cause the rising instances of urban floods in the country. Now, we the society, we the man and the society are also equally responsible. On one hand, the extreme meteorological phenomena are rising. On the other hand, the built-up also is increasing. So this is causing the rise in impervious surfaces. Now, these rise in impervious surfaces, no, they were used to absorb the excess water. Now, instead of absorbing the water, they are releasing the water. So the two important phenomena and two important ends, they are going to the extreme category. So urban floods are going to occur. So there are studies that if 1% impervious surfaces are increasing, particularly in the pavement, then the flood instances will rise by nearly 3%. So there are studies that the rise in built-up will give the rise to the impervious surface, and this rise in built-up imperviousness will give rise to the urban floods. So that's how we carried out the study. We were fortunate; we had some high-quality digital elevation model available for the city. Why so? We can carry out the study using the traditional methods and the traditional data sets, because such studies require the urban micro catchment delineation and the stream urban drainage, stormwater drainage network wise micro catchment delineation. Both the drainages and their micro catchment has to be delineated. You see that because undulation within the city may not be very high, the traditional sources to derive the DEM, digital elevation model, will not be so strong in terms of resolution or other characteristics. That's how we are fortunate that the city is pronounced well as the top ranking in the smart city. At the same time, it is facing the instances of urban floods, and we were fortunate we have got such kind of DEMs. But if the such kind of DMs are not high quality, DMs are not available, you can carry out the study using the other sources of DM. You see on the right hand side, we try to delineate the micro catchment and the drainage network, because the city had got the stormwater drainage network present. When you try to match the drainage network mapped by the authorities, but vis-a-vis the drainage network which is derived using the DEM, we found that there is a total mismatch. When we try to do the same kind of urban drainage system and derivation using the LiDAR-based DEM, we found to be very, very accurate. So that's how the such kind of data sets are available. If available, they will help you in the improved analysis. Now, beyond that, what we try to use, we try to use the conventional models like SCS just to understand that what are the runoff potential which are available, characteristics which are prevalent along the entire catchment. Now, this Bhubaneswar city falls within the catchment of a river. Okay, so it has got a Kokhai river, and then which has got a large catchment. So, because any kind of hydrological models, they are run on the, rather than the administrative boundary, it has to be run on the natural catchment boundary. First of all, we try to understand what is the runoff potential across entire catchment. There are studies where people have tried to assess the runoff potential in the temporal domain. So, sorry. So this analysis has helping us that which are the areas which fall under highest runoff categories. So if you got this kind of simple to do analysis, no, you can find out the priority zones. So first, such kind of priority zones for the entire catchment, we have tried to use the model like stormwater management model, which is built on pluvial flood characteristics. When it tries to assess that based on urban stormwater drainage characteristics, its junctions, route, conduits, and outfalls. And then we based on water balance technique and using the also based on the Manning's equation, where we tries to assess the hydraulic properties of the stormwater drainage network, tries to assess at what is the capacity to hold the runoff which is coming into these kind of a storm drainage network, at what point the capacity will be overwhelmed and the street will be waterlogged. So this kind of analysis is feasible, and how long this water will remain stagnant, and then which are the areas are affected, and then what are the remedial measures that has to be adopted. And then if you got the coping capacity of the society or the infrastructure, which are the vulnerable areas, and then we can do the risk modeling. That's how we try to do, and then try to find out that variety of rainfall intensities or variety of return period interval based on IDF curve analysis, which are the areas which will get for varying intensity of rainfall based on rainfall return period analysis, how and how much the depth of urban floods will be there, and which are the areas which will be affected. So this has become an output to assess the urban flood hazard for varying intensity of rainfall and based on carrying capacity of the stormwater drainage network. Then we also try to find out that what is the triggering volume or the depth of the rainfall, which will beyond which the stormwater drainage capacity will be overwhelmed. And then such kind of if you got this kind of analysis, so we can also think about the flood forecasting. So then we also try to assess the vulnerability capability of the settlements based on their house characteristic, distance from the river, and whether the structure is it's a kacha structure or is a pakka structure, and then based on the economic characteristics of the urban dwellers, we try to find out which all areas which are highly vulnerable and where the vulnerability is low. Then after subjecting the vulnerability and the hazard, we try to find out varying return period interval, what is the risk characteristics for the catchment. Okay, so this how the urban flood risk modeling can be carried out, and then we can go towards the remedial measures. Now, what kind of remedial measures has to be adopted? First of all, we have to understand that in our society, the stormwater drainage network and the sewerage network, largely they are same. Okay, so that's how the immediate utilization of the stormwater is not possible unless we purify it. So that's how this is one of the important points. In certain planned areas, these two segments are different, where the immediately the water, the rainwater harvesting we can think of. But if such processes are not different, then itself is an issue. So in terms of remedial measures, first of all, we have to think about what we have to improve our drainage system. We have to also clear our water bodies from the encroachment. We have to increase the urban green spaces. So such kind of studies also we try to do, and then also we try to assess that if this kind of business as usual scenario is happening, then what will happen? Based on urban growth modeling, we could foresee that under the business as usual scenario based on urban growth modeling techniques, that how the built up area is there in the past, in the present, and then what is going to happen in the future. So if the more built up area is going to increase, certainly is going to add more pressure on the existing drainage system. So if this is going to happen, then the urban flood hazard is going to increase further. So what are the remedial measures? So as I said, that we have to manage our blue and green infrastructure effectively. We have to create that awareness within the society, and then always there are building bylaws are there which are dictating, but the regulation methods, they are weak, as we all know. That's how we have to strengthen such system, and one such system is managing the green infrastructure. So green infrastructure or the urban green spaces, they are very, very important. They have to, we can manage such kind of green spaces either on the roof, on the facade, or on the pavement, or in the vacant spaces. If we do so, then we try to do the study that what what is the effect of that if the urbanization processes are increasing, how the runoff will further increase. If the urbanization process is curtailed and we introduce the greenery intervention, then what will happen? So this kind of scenario based analysis we try to do based on urban growth modeling principles, based on urban green spaces suitability analysis. Once we did, we found that if that is so, when you're doing it, so we found that there are possibilities that based on urban green spaces and based on urban building bylaws, it's which dictates that an individual household should have how much the tree cover or the vacant spaces present within the area, how should be made further green so that they absorb the water. So we try to do the suitability analysis either for the growth modeling, so which are the areas which will be further come under the urban spaces, or which are the areas if the remedial measures are adopted or regulated, so which are the areas we can put more under the green. So if that is so, when you're doing it, we are going to reduce the under the scenario based GIS based analysis past scenario. That means what was there in the past 2005 baseline scenario means at present, because the study was done 2 years back. CVS scenario means if the urbanization processes are happening under the business as usual scenario, or the green spaces scenario. Suppose we introduce the more and more greenery, so for varying return periods we are going to reduce the runoff, and particularly the peak runoff. So these kind of remedial measures or the intervention, what if scenario that can be built using the remote sensing data and using the geospatial technologies, that's how we can convince ourselves, we can convince the society, we can convince the decision makers that these kind of interventions are necessary to make our society, our city more livable than the what is happening or what will happen in the future. So as such, these are the preparedness phase. That means either the preparedness or the early warning based on geospatial modeling we can carry out, and we can see that what is happening, what should we do. But if the disaster has struck, that means any urban spaces they have got under the water and urban flooding has occurred, what should we do? So that's how we may, in such cases, because there are procedures have been built globally by the spacefaring nation where the data is being shared. So, but again, there's an issue that in the context of urban floods, because when the floods are there, that means clouds are present. So that's how the optical data has got constrained. So in such cases, we have to resort to the other data sets like the microwave. Or if we are fortunate, then in the subsequent days, we can find out if the cloud is clear, we can find out the affected areas. If that is so, we can find out which are the areas which are marooned and which are the area which are getting clear from the water, and that's how the relief and the restoration activities and the response can happen from from the administration. So that's how these kind of data set in the subsequent phases that can occur. So while the question is why the under the urban hazards, why the floods occur, one important point that we treat our river as a dump yard rather than keeping them safe. We worshipping them. We keep our such kind of river system as our our own property, and that's how we dump the solid waste, and then also we encroach in the banks, and then that's what happens. And you see here that is a temporal data set, two time series data sets on the open source platform. You see that in the past, it's a part of a city. You see that there was a lesser built up spaces were there, more and more greenery was present. At the same time, the river was also wide. But as the urbanization happened, we have killed the green spaces, and also we have encroached upon into the floodplain of the river. So what will happen? So after effects are well known. So that's how that we have to be alert, and then regulatory bodies can use this kind of ready-to-use product which are available in the public platform, public domain, and then kind of awareness and the regulatory measures have to also we have to adopt. Then the question, one more important point is in terms of cleanliness. That's also very important, because the what happens, the such kind of solid waste, they also choke inlet to the stormwater drainage network. So this kind of urban drainage system is very, very important. In some part of the world, we talk about SDUSS, that is the Sustainable Urban Drainage System, which says that the stormwater drainage network and also the sewerage network, they will be treated separately, and there will be procedure for rainwater harvesting at household level, and also for the groundwater recharge. Then what is important that in our country or elsewhere, we prepare the master plans. So master plan is a document which also signifies the future built up. So when we prepare such kind of master plan, we should also think about at the simultaneously that we have to also come out with the water master plan, sewerage master plan, and stormwater master plan. So this way, such kind of philosophy we build in our planning process, then this kind of disasters which later cost heavily, that can be minimized, that can be reduced. So in that context, the Ministry of Housing and Urban Affairs and the erstwhile Ministry of Urban Development, they have prepared an SOP document that on the urban floods. So this document lists and tries to illustrate that what kind of measures should be adopted in the planning process so that the city become resilient to the urban floods. So we have got as I said, urban floods instances are rising, and we have to model, we have to monitor, and also we have to create awareness. But in terms of monitoring and modeling, there are challenges. Challenges in the sense like we have to, because the spatial variability of the rainfall that is changing with the passage of time because of the so-called climate change phenomena. We have to also look for a short duration rainfall. It's not the average 24-hour rainfall. We have to look for the sub-hourly rainfall kind of information is required to predict, to forecast, to understand the urban floods. So that not in the average form, average data, because when you say average, that means by the time the water would have been evacuated from the region. So that will not be useful. We also understand the city topography, and then we have to go in the times to come. The endeavor is going on for the real-time forecasting, and which itself is a big challenge. Coming to the second disaster, that is the seismic risk assessment, that as the urbanization processes are happening, so built up area, land gets costly. So when the land becomes costly, then people often they ignore the building bylaws, then distance between the buildings will be lesser, and they'll be closed by, and also the educate structural measures because of the economic reason might not be adopted. And that is how we try to see that because of the, try to simulate that because of the given intensity of rainfall defined in terms of PG of pre-ground acceleration or based on modified Mercalli index, that is MMI, what kind of losses are going to occur. So in this context, again, we try to use a model called radius, where we try to define, first of all, the properties of the urban layout. After defining the properties of the urban layout in terms of age, in terms of adjacency, in terms of distance, etc., then we try to model in terms of varying intensity of the MMI. When we did the various kind of information data sets, they were produced ranging from what kind of land use is in the practice, then what kind of building types are there, roofs are there, age is there, what is the distance between the buildings, and then we try to model that based on different intensities of seismic earthquake, which are the areas which are going to be affected. So in this context, we have generated the damage probability matrix. So which states about that putting the building into different categories based on whether it is load bearing or a frame structure, what kind of roof is present, whether then in terms of layout of the building, are the building maintained? Some of these data sets were collected from the ground, and what is the age of the building, and then whether it is the based on income group or based on other characteristics, whether it is the informal settlement or the slums, etc., we try to find out that which are the areas and which are the buildings which are most vulnerable. So as you see that the damage probability will increase from minimum to maximum as the earthquake intensity is going to rise. And then we also try to find out for different kind of building types and building age, what are the areas which are going to be affected. So as such, you see that sorry, we try to find out that based on intensity of earthquake, which are the areas and which are the buildings which are going to be affected. Now, such kind of analysis, no, as you see, it's very data intensive, and some of these data has to be collected from the satellite, and some of these data has to be collected extensively from the ground. So that's how such kind of models are data intensive, and also we try to find out that which are the roads, because of such kind of disaster going to strike, then certainly the evacuation measures have to be adopted. Then which are the roads which will get blocked because of the after effects of the seismic hazard. So this how is an example where the urban seismic risk assessment can be carried out at micro level. Now, coming to the after the land surface, that has come to the atmosphere. So as our anthropogenic activities are rising, it is also affecting our environment. So in terms of environment, particularly the elements which affects our environment are the NOx, SOx, and the carbon monoxide and the particulate matter. So we try to do the ground-based and also the satellite-based analysis. So using the instruments, in situ instruments, we try to find out in a city that across the time, across the spatial domain, and because of the at different junctions in a city, what is the trend of these pollutants, gases, or the particulate matter at different times. We try to find out that which are the affected regions, at what time, at what space it gets affected the most. And then if these are the things, certainly the question is the dwellers, urban dwellers, who are traveling in those areas or who are living in those areas, they're going to be most affected. Now, in the recent times, no, we have got a satellite, and though there are several satellites, no, they are helping us to monitor our environment. One such satellite is the Sentinel 5P precursor. So it has got a sensor which is based on imaging spectroscopy. It is trying to assess the gases and the particulate matter. Then we also try to use these data sets that we had a pandemic, we all are aware, in the 2020. And then we had the lockdown in the country and elsewhere in the world. That during the lockdown, in different phases, how our environment got clean, and during the subsequently opening process, how the environment got affected. So this way, we are seeing that how our environment is getting affected, and such kind of measurements are feasible using the ground-based instrument, so which will be based on the imaging spectroscopy or based on the some kind of filtration technique when we expose the filters to the pollutants and then go to the lab and try to assess how much it has absorbed over a period of time, or it will be based on several satellites, which are measuring such kind of pollutants. Okay, and then we are able to assess which are the areas where the pollution is high or low. But subsequently, what is more happening in the country, in the research domain or elsewhere in the world, that people are trying to interlink such kind of processes, and it's also the features, parameters, that how the built form is affecting the pollution or otherwise. So this kind of interlinkages, that's also feasible, and studies are going on. Now, coming to the other hazard, that is the fire hazard. So now, what is happening anytime when a fire strikes an area? So immediately, first of all, we have to equip our society, or we have to equip our urban population, so that such kind of hazards should not strike our society. But because of any kind of practices what we adopt, or because of any kind of abnormal meteorological phenomena, such thing appears to be inevitable. So one such phenomena occurred in 2009, where from an industrial plant where the fire struck, and it was the oil depot. So oil containers were there. Within no time, the fire got bludgeoning flames. They spread all around. So it has formed a plume, as you see in the satellite data, and the authorities came into the action, and the evacuation measures and the remedial action immediately was taken. So what the geospatial technology can do here, there are models, like the Aloha, which is a tool for understanding the area locations of hazardous atmospheres. This is like kind of a preventive exercise. Suppose for an industrial plant, which is categorized under the red category by the authorities, and then suppose, though even after taking the sufficient precaution, if any kind of such disasters they strike, then what can happen? So this kind of scenario generation is feasible, that we can use variety of data sets, and we can find out which all areas which are going to be very, very vulnerable based on prevalent intensity of radiation, prevalent wind characteristics, prevalent other meteorological characteristics, on which areas are going to be affected. So that is so, then where in advance we can create some kind of sense in the local population, that there either the urban density has to be minimized, controlled, or where we have to keep in mind that if such things happen, how we can go into the response and the relief phase. Okay. Another domain which I'll not touch upon at greater length, for the reason being that it is the very itself is a topic, separate topic for itself, where a separate lecture is required. But in the urban areas, because of the anthropogenic reasons, because of the biological reasons, because of the environmental reasons, the health risk is rising. And the use of GIS in the health GIS was demonstrated long time back in the manual GIS. A professor, John Snow, he in 1854, he mapped the occurrence of cholera epidemic. So when he mapped it, so what he found that when he tried to follow the traces of this epidemic, he landed up to the finally to a water body. So he found that that particular water body is the source from where the water is being pumped, and then it is creating the cholera into the entire region. That's how the source, not genesis of this kind of hazard that was being mapped, and then that's how the preventive actions were being taken. So this is an application where the health GIS that can be addressed, and the the geospatial technology can be used. So as such, health GIS, whether it is the vector borne or it is otherwise, so several kinds of examples are there, and this itself calls for a separate lecture where examples are present. And particularly in the case of no, in the when the pandemic it struck our world globally, then there were several examples are present in the internet world where the people have created the COVID-19 kind of dashboard where globally you are able to see click of a button where the cases are prevalent and where the newer cases are happening, and where the some kind of cloud GIS and the people GIS kind of phenomena, citizen-centric kind of application, they have been taken up to understand the dominance of this kind of disease, epidemic. So that's how the example was shown. Now I'll move to the another example, that is the UHI, urban heat island phenomena, which is the anomalous temperature phenomena within the city environment, which is first of all, which is primary source is the meteorological, but this thing happens and become prevalent anomaly in some pockets of the city because of the change in the land surface. So as the land surface changes from the rural to the in the urban or the industrial, its temperature regime also changes. So this kind of temperature regime that can be mapped, monitored using the satellite-based sensors which have got the thermal bands. So there are several satellites which are present and where the land surface temperature, no LST mapping is feasible. Once we map the LST within a city environment, then we can find out the anomalous behavior within the city, either it is in the night time or in the daytime. So that's how we are able to find out which are the areas which are going to be very, very warm or warmer, or which are going to be cooler either in the daytime or the night time. So this way, again, there's a kind of output which can go into the planning process. So once this kind of outputs are there, secondly, it calls for some kind of remedial measures. And then in terms of remedial measures, because we have to look for the features which can induce the cooling phenomena. And of course, you will agree that such kind of features which can induce the cooling phenomena are either the blue infrastructure or the green infrastructure. So that's how such kind of interventions are available. They have to be enforced. Now, coming to the another example, the cultural heritage. So again, either it is the mapping or monitoring or the modeling. In example, I'm trying to demonstrate here that there's a famous Buddhist temple in the East Asian country, where when the earthquake struck, before and after, the building and particularly its facade got damaged. So once this all phenomena happened, this was well captured by the satellite data. So the question comes, this we can monitor it, but at the same time we have to periodically, we have to also understand that, because either they have to be periodically monitored by entire its facade, that that which are the part of that structure where the vulnerability is has come or which is present. So that's how, in order to understand the vulnerable part of the structure, we try to utilize the terrestrial laser scanner kind of device, and we have created the 363 view all around it, and then we try to assess the, first of all, a part of the building, part of the structure where the cracks are present, because the when the TLSS was used and with the sufficient overlap, then we are able to generate the point cloud. When we recreated this kind of point cloud, we found some kind of anomalous pattern in linear shape. So this anomalous pattern, which is nothing but the kind of crevice or the cavity which has come into the structure because of the external wind or water reason. Okay, so we are able to map it, such kind of crack in the structure using the instrument like the TLS. Then subsequently we try to also find out that in terms of some kind of preventive exercise, is this structure has got a strength in terms of its own characteristics, physical characteristics, or its ambience, whether it is capable enough to withstand the kind of disaster that may strike in the future. So accordingly, we use two kind of index, like the urgency index or the redevelopment potential index, based on variety of inputs. That, so these inputs are the building specific or the vicinity specific, and then we try to understand that what is the vulnerability of a given structure to withstand such kind of disaster in the future. So as such, I try to give some illustration that how our cities are becoming more and more disaster prone. Then, because our vulnerability characteristics are also increasing, our coping capacity is reducing because of the rising urban pressure. And on the same time, extreme event phenomena, or the so-called this climate change phenomena, are also rising. So what are the challenges ahead? So the challenges are like there are studies by the IPCC. Our temperature is going to rise, and then the number of rainy days and the extreme rainfall event, they are also going to rise. There are also prediction that sea level is also going to rise. So the cities which are coastal, cities which are in the high rainfall region, cities which are in the high seismic risk zones, cities where the population pressure is very high, areas where people are not following the educate building structural norms. So such places, the pressure is going to be very, very high. And such places are going to face the risk of urban hazards more and more in the times to come. So that's how we have to go for the efficient land use planning, and we have to retrofit or strengthen our building and our environments. If that is so, that's how our urban local bodies, they have to adopt to go efficient land use planning, waste management, energy consumption, master plan preparation and enforcement, those things are necessary, so that if you do so, then we are going to increase our coping capacity, we'll become more and more resilient, and we have to adopt appropriate risk assessment tools. We have to strengthen our building and our environment. We have to strengthen our relief and restoration processes. Okay, and then we have to go for what is so. Periodically, we have to carry out the mock and the drill analysis. We have to this geospatial technology based scenarios, they have to be adopted by the decision makers. You have to convince them so that our cities become more and more resilient. So with this, I end up to my deliberation, and I'm thankful to you all, okay, for your patient hearing, and I'll be happy to give the answer to your queries. Thank you very much.